Okay, today we're going to be talking about the mean value theorem. The mean value theorem, not to be confused with the extreme value theorem, which we just talked about, or with the intermediate value theorem that we talked about a long time ago. Mean value theorem has to do with this word mean. Mean meaning average. So here's a picture of what's going on. You've got this function f, which just sort of merrily rolls along here. This is f, and the function goes from some number a, oops, seem to have lost where I am. The function starts at a, and it goes all the way over to b. And in going from a to b, one of the things that we compute is the rate of change. Well, the first rate of change that we talked about, which was this one, the average rate of change. We calculate f of b minus f of a, which is the difference in the y values, and then we divide that by b minus a, which is the difference in the x values. So if you think about the difference in the y values divided by the difference in the x values, that of course is a slope, and it's the slope of a line that connects these 2 points, this one and this one. Now, in the interest of not mucking up the picture too much, let me change the color of this. Let's make it a nice friendly green. So if we connect these 2 points with this nice green line, which is supposed to be straight, then the slope of that line is this number that we just wrote down here. This number is the slope of that line because if you calculate the difference in the y values, that would be f of b, that's this point's y value, minus f of a, which would be this point's y value, and then you divide that by b minus a, which is of course the length of that. So that's going to give you the slope of this line. So you could call that number m, which is the slope of this line. The mean value theorem says something about this average rate of change, this slope, which is the average rate of change in going from this point to this point. The average rate of change doesn't capture much. It doesn't tell you what's going on in between. You know, for example, you could have taken off from this point and gone very, very, very fast and then just sort of coasted the rest of the way, not changed speed. Or you could have gone sort of straight across, following the line, constant speed. Or you could have started off by not doing anything and then in the last 5 minutes just raced all the way. And this average rate of change doesn't capture any of that. But what the mean value theorem says is that this average rate of change has to be equal to the instantaneous rate of change, which of course is the derivative. And the only catch is we don't know where that would be, except that it would be somewhere between a and b. If you look at this picture, you can notice that at some points between a and b, it looks like if you calculated the tangent line like right there, the tangent line right there would be parallel to that green line. Let me just draw it for you in red. So if you drew a tangent line right here, it'd be pretty much parallel to that one. Similarly down here, there'd be a point somewhere around there where the tangent line is going to be parallel to the green one. And in this case, there are quite a few. There are several of these points. Now, I'm not going to draw all of them, but there are places where the tangent line is going to be parallel to the line containing those 2 points, a, f of a, b, f of b. And what the mean value theorem says is that there's at least one place, and in this case there's probably 4 or 5, but there's going to be at least one place, like this one for instance, which we'll call at c. The derivative at c would be the slope of that red line there. The derivative of that slope, the derivative of that line, the slope of that red line, is going to be exactly the same as the slope of the line connecting the endpoints. So in other words, the average rate of change, to put it in English, the average rate of change, that's what's on the left, equals the instantaneous rate of change. This is the instantaneous rate of change. There's words missing still. Where? Where does this happen? And the important thing is that it happens somewhere. That it happens for at least one, for some value C that's between A and B. All right? The mean value theorem does not tell you where that is, but it guarantees that there's at least one. You can't go from here to there without having an instantaneous rate of change somewhere. There exists a point somewhere between A and B where the instantaneous rate of change is going to be exactly the same as that average rate of change. So to put it in real life terms, you can't drive from Valparaiso to Merrillville and average 30 miles an hour without sometime between your trip from Valparaiso to Merrillville, sometime you had to have been traveling exactly 30 miles an hour, at least once. You just can't do it otherwise. You could be traveling very, very slow for a while and then speed up at the end, but at least at one moment you're going to be traveling, you're going to have to be traveling that average rate of change, whatever it is. Okay, let's illustrate this with an example. So let's suppose that we take our favorite function here, f of x equals x squared. And I want to look at it on the interval from, let's say, -1 to 3. So here's the picture of what we are dealing with. Of course, everybody knows that you're going to get this beautiful parabola. And it's going to come down like that, and then grow like that. Okay, and then we need to identify where is -1. It's about here, let's say. And then 3 would be maybe around there. Okay, so what's the average rate of change in going from -1, which would be that point, to that point? I can draw the line again. Let's do it again in green. That's the line that connects these 2 points. So you just go just like that. And that's the line connecting those 2 points. That's the average rate of change. And we can compute that. The formula for it is f of b minus f of a over b minus a, the slope in other words. So for this function, that would mean f of b, f of 3, which would be 9, minus f of -1, which is -1 squared, that's 1, divided by 3 minus -1. 3 minus -1 is 4. So that's going to be 9 minus 1 is 8 over 4, which is 2. So the slope of this green line, you can write it up here, m equals 2. Mean value theorem says you can't go from -1 to 3 without somewhere between -1 and 3 having a point where the derivative, the instantaneous rate of change, is going to be the same as the average rate of change. Well, if you look here, the tangent line's going down. That's no good. Down here at the origin, tangent line's horizontal. That's no good. But somewhere around here, maybe, you're going to have a tangent line that's parallel. Where is that point? We can do that. We can calculate it. Because we know the slope of the tangent line everywhere. That would be the derivative, f prime of x. And for this function, it's pretty easy. Even high school kids know that. F prime of x is 2x. So that's the derivative at every point. But we're not interested in the derivative at every point. We're interested in the derivative at one point only, where the answer is going to come out to be 2. So please notice, I'm not saying the derivative at 2. I'm saying the derivative's equal to 2. The derivative is going to give you a value that's equal to 2. The slope of the tangent line is going to be 2. So that means 2x is equal to 2. Well, that's pretty easy. X equals 1. And on this picture, you can see that if you go to 1, yeah, sure enough, looks like the tangent line there, if I draw that in red again, the tangent line right here is going to be parallel to what that green line is. So, in fact, this function has at least one point where the instantaneous rate of change is equal to the average rate of change. And that's all there is really to it, the theorem of the mean value theorem. Now, this theorem, unfortunately for us, is a very important theorem in mathematics, but it's not that important for us right now. You need to know it just so you can get past the exam, but it doesn't pop up in most of what we do in Calculus 1. But it turns out to be very important in many, many proofs, and it's very important to understand in certain things that come up a little bit later. So at this point, it's a good time to introduce you to the mean value theorem, but other than that, there's not too much more to it. So that's about it for now.